In this video, I'm going to show you how to factor quadratic expressions. Now, it seems like there's different techniques depending on what the expression looks like, and there actually is. There's many different tricks and tips that I can show you. Now, before I do that, we can see that factoring a quadratic expression is actually the opposite of multiplying two binomials. Well, at least often it is. So I'm going to show you this first one, where you can see that when we multiply two binomials together, which only differ by the sign in the middle, you're going to get something called a difference of squares. So for example, if I take x minus 3 and x plus 3, I'm going to multiply the first terms to get x squared, multiply the first and the last term to get plus 3x, multiply the two middle terms, minus 3x, and then the last two, I get negative 9. Simplifying, I get x squared minus 9. So notice that the two middle terms, they cancel off. Let's take a look at the second one. So we have 2x times 2x, 4x squared, multiply the first and last, 2x times negative 5y, negative 10xy, the 2 in the middle, so plus 10xy, and then the last terms. So 5y times negative 5y is negative 25y squared. So notice again, the two middle terms are the same. So we get 4x squared minus 25y squared when we simplify. So if you notice, these are only quadratics with only two terms. So when I work in reverse and I want to factor these difference of squares, notice they're called that because the sign in the middle is a minus, and each of the single terms are squares. Then we're going to get two binomials when we factor, which only differ by the sign in the middle. So what I'm talking about is going in reverse. Okay, so x squared minus 9, when I factor, I get a minus and a plus. And then the terms, or each of the terms, are the square root of each term in the quadratic. Okay, so let's take a look at an example. So here we have x squared minus 36y squared. Okay, so it's a difference, and each of these are squares. So I know that it's going to be two binomials. One's going to be minus, one will be plus. I square root x squared, and that's going to be x. I square root 36y squared, and that's going to give me 6y. And that's what I put in the second term. So if we multiply this out, you will notice that we would get this. And it's often good, and always actually good, to check. Okay, for the second one, even though these are fractions, we can see that all these numbers are all squares, and same with the variables. So we're going to have a minus and a plus. So the square root of 4/9 m squared is 2/3 m. And the square root of 49 over 81 n squared is 7/9 n. All right, now I'm going to show you a different type, and these are called perfect square trinomials. When you multiply two binomials, which are the same, so we have 3x plus 2, you're going to get something called a perfect square trinomial. I'm going to show you how to do this and see what the result looks like. Now remember, when we square a binomial, it means that we actually have two binomials. So I'm going to rewrite this out as 3x plus 2 times 3x plus 2. Now, a common mistake is that students think that we go 3x squared and only 2 squared, but that's incorrect. That won't give you all three terms. So we're going to go 3x times 3x is 9x squared. Get my middle terms, which is 6x plus 6x, and then 2 times 2, I get 4. So here I have 9x squared plus 12x plus 4. So notice where this middle term comes from. The 12x is from adding two of these which are identical. Okay, let's take a look at one with a minus. So I'm going to rewrite this out so that there are two of them first. Okay, and I'm going to distribute. So I get 4x times 4x is 16x squared minus 20x for my middle terms, and then plus 25. And we can simplify this to become 16x squared minus 40x and plus 25. So notice again that this middle term, negative 40x, is obtained by 2 times 20x, or negative 20x, because we have two of them. Now, how do we check? Because if we can check that this is a perfect square trinomial, I'll make factoring a lot easier. So what you can do is we're going to take a look if that middle term can be obtained by multiplying two times because you have two of those middle terms which are identical. So 2 times, and then how do we get that middle term 6x and 6x? Well, notice that it's from 3x and 2. However, we don't know that because we haven't factored it yet. But notice that 3x is a square root of 9x squared, and the 2 is a square root of positive 4. Just like 4x is a square root of 16x squared, and the negative 5 is a square root of 25. Now, we'll talk about why this one's going to be minus in a bit. So what we can do is we're going to check the middle term by multiplying 2 times the square root of the first and third term. So let me show you what this means in an example. So if we take a look at this first example here, the square root of 4x squared is 2x. The square root of 25 is 5. And if I take those two and I times it by 2, times it by 2 because there's two of them, okay, I do get 20x, which is my middle term. That means that this quadratic is actually a perfect square trinomial. So because it's a perfect square trinomial, I can factor this very easily. So the square root of 4x squared is 2x. The square root of 25 is 5. And there are two of them. Two binomials that are identical. And then we can rewrite this as 2x plus 5 all squared. So again, what I'm doing is to check if that middle term, the 20x, is 2 times the square root of the first term and the third term. And if it is a perfect square trinomial, which means that I can factor it very quickly to be 2x plus 5 and 2x plus 5. So let's take a look at another one. So the square root of 64x squared is 8x. The square root of 9 is 3. Timesing that by 2, I get 48x. That's great, because that's what I have for my middle term. Now it is minus, but that's okay. So we can always say that it's a perfect square trinomial as long as the two signs are both positive, or the first one is negative and the second one is positive. So when I square root 64x squared, I get 8x. Square root 9, I get 3. Oh, and I put a plus by accident, and that should be minus. And then I have 8x minus 3 as well. So the reason that it is minus and positive is because when I multiply 8x and 8x, I get the 64x squared. But this 8x times negative 3 will give me a negative. And then I have another negative to give me the negative 48. And then negative times negative will give me the positive. So it's only positive, positive, and negative, positive that will be perfect square trinomials. So we can rewrite this now as 8x minus 3 and all squared.